going to start our next chapter, that is application of derivative. क्वेश्चन स्टार्ट करेंगे आज हम इसके. फर्स्ट टाइप इज डेरिवेटिव्स एज rate measurer. We'll start this topic today. Let us start with the questions. Write down the first statement. A balloon which always remains spherical. Balloon is in the sphere form. Has a variable radius. Find the rate at which its volume is increasing with respect to radius. क्या कहा है हमें? बैलून है स्फेरिकल फॉर्म में, हमें वो रेट निकालना है जिसपे इसका वॉल्यूम इंक्रीज हो रहा है विद रिस्पेक्ट टू रेडियस. व्हेन द रेडियस इज 7 सेंटीमीटर, जब रेडियस की वैल्यू 7 सेंटीमीटर है. नाउ वी नो वॉल्यूम ऑफ स्फीयर क्या होता है? 4/3 पाई आर क्यूब, यही होता है. लेट इट डिनोटेड बाय V. Now we want to find dV upon dr. So differentiate this with respect to r. What we get? dV upon dr 4/3 pi. Derivative of r cube is 3r square. So we get 4 pi r square. Now we want to find rate of change of volume with respect to r when r is equals to 7. Put this value 4 pi 7 square. 7 square is 49 into 4 pi. 196 pi. Unit of volume is, radius is 70 centimeter. In centimeter, volume का unit है centimeter cube और radius का centimeter. So dV upon dr, therefore the unit will be centimeter square. Now the next one, find the rate of change of area of a circle. Area of circle with respect to radius. हमें इसका rate of change निकालना है. How fast is the area changing with respect to radius when the radius is 3 centimeter? This is given area of a circle. What is the formula for area of circle? That is pi r square. Let it be denoted by A. Now we want to find dA upon dr. So differentiate with respect to r. What we get? dA upon dr pi r square का derivative 2r. Now we want to find the value of dA upon dr when r is 3 centimeter. So 2 pi r is 3. So what we get? 6 pi centimeter. Unit of area is centimeter square. Radius is centimeter. So 1 centimeter will get cancelled. We get the unit as centimeter. Note it down. Now the next one is a balloon which always remains spherical has a variable diameter. Diameter of balloon हमें given है 3/2 2x plus 3. Determine the rate of change of volume with respect to x. This is what we want to find. Clear? Now volume of balloon. Balloon is in spherical form. Let volume be denoted by V. Then volume of balloon be 4/3 pi r cube. Clear? Here we have given the diameter. Radius is equals to diameter upon 2. Then radius is 3/4 2x plus 3. Clear? So instead of radius, we have to put the value of radius here. 4/3 pi 3/4 2x plus 3 whole cube. 4/3 pi 2x plus 3 whole cube. 9 pi by 16 2x plus 3 whole cube. ये अभी हम वॉल्यूम की ही सिंप्लीफिकेशन कर रहे थे. Now we want to find dV upon dx. Now differentiate it with respect to x. Differentiate with respect to x. dv upon dx 9 pi by 16 3 2x plus 3 whole square. Then derivative of 2x is 2 and 3 is 0. So what we get? 27 upon 8 pi 2x plus 3 whole square. This is value of dv upon dx. Volume is in, the unit is not given, so what will be the unit? Square units. Now the next one is question number 4. The total cost Cx associated with the production of X units of an item is given as 0.005 x cube minus 0.02 x square plus 30x plus 5000. Find the marginal cost when 3 units are produced, whereby marginal cost we mean the instantaneous rate of change of total cost at any level of output. Marginal cost is equals to derivative of function this with respect to x. Take the derivative. 0.5 into 3. 5 into 3 is 15. So 0.015 x square. 2 into 2, 4x plus 30. Clear? Now we want to find the marginal cost when 3 units are produced. Put the value here. 3 square minus 0.4 into 3 plus 30. 3 square is 9. 15 into 9, 135. Minus 4 into 3, 12 plus 30. So what we get? 30.135 minus 0.12. 0.015. So we get 30.015. Now the next one. The total revenue received from the sale of X units of product is given by Rx as 3x square plus 6x, 36x plus 5. Find the marginal revenue when x is equals to 5, whereby marginal revenue we mean the rate of change of total revenue with respect to number of items sold at an instant. So we want to find dr upon dx. 3 into 2, 6x plus 36. Now we want this value when x is equals to 5. 6 into 5, 30 plus 36. That is 66. Therefore, required marginal revenue is rupees 66. A car starts from a point P at time t is equals to 0 and stops at point Q. The distance x in meters covered by it in t seconds is given by x is equals to t square 2 minus t by 3. Find the time taken by it to reach at Q and find the distance between P and Q. X is equals to 2t square minus t cube by 3. Differentiate with respect to t. 2 into 2, 3t square by 3. So we get 4t minus t square. Write down. This gives the velocity of car at any time t. Now, suppose the car stops at Q. Suppose car second, then at t is equals to t1, dx upon dt equals to 0. So 4t1 minus t1 square. Take t1 common. So what we get? T1 is 0 or 4 minus T1 is 0. T1 is 4. Therefore, the car takes 4 seconds to reach at point Q. Now distance between P and Q. Distance between P and Q was x. So x is equals to 2t square minus t square by 3. Put the value of t. 4. 4 square 16 into 2. 2 into 4 square minus 4 square by 3. So what we get? 80 by 3. Here we have t cube. So 4 cube is 64. 96 minus 64. 32 by 3 kilometers. So the distance is, x is in meters. So this is 32 by 3 meters. Note it down. Now the next is related rates. Questions related rates. Let us start. An edge of a variable cube is increasing at rate of 10 centimeter per second. Let x be the length of edge of cube. क्या कह रहा है? H increasing, an edge of variable cube is increasing at rate of this per second. So dx upon dt. How fast the volume of cube is increasing when edge is 5? When edge is 5 centimeter long. We want to find dv upon dt when edge is 5 centimeter. Now we know volume of cube is side cube. ठीक है? Volume of cube is side cube और side हमने कितनी मानी है? x. Now differentiate with respect to t. 3x square dx by dt. dx by dt की हमें value given है 10. So 30x square. Now we want to find this value when x is equals to 5. So put the value 5 square 25 into 3 750. 750 volume is in centimeter cube and time is in second. So 750 centimeter cube per second. Clear? Next one. The radius of the circle is increasing uniformly at rate of 4 centimeter per second. Radius is increasing uniformly at rate of 4 centimeter per second. Find the rate at which area is increasing when radius is 8 centimeter. Now, area of a circle. This is what we want to find. Area of circle is pi r square. Let area be denoted by A. Differentiate with respect to t. Pi 2r dr by dt. 2 pi r dr by dt is 4. So 8 pi r. Now we want to find rate of change of area with respect to time when r is 8. So 8 pi into 8, that is 64 pi centimeter square per second. Now the next one is radius of the balloon is increasing. Radius of the balloon is increasing at rate of 10 centimeter per second. At what rate is the surface area of a balloon? Let surface area be denoted by S. When the radius is 15 centimeter. This is what we want to find. Now, balloon is in spherical form. Now, surface area of a sphere. What is the formula for surface area of sphere? Is 4 pi r square. Let it be denoted by S. Now, differentiate with respect to time. 4 pi 2r dr by dt. 8 pi r dr by dt is 10, so 80 pi r. Now we want to find surface area, rate of change of surface area when r is equals to 15. So put the value of r 15. So ds by dt when r is equals to 15 centimeter is equals to 80 pi into 15. 80 pi into 15. So what we get? 15 into 8, 120. So 1200 pi. Surface area will be in centimeter square and time is in second. So centimeter square per second. Next one is, a stone is dropped into a quiet lake and the waves move in a circle. अगर आप पानी में स्टोन थ्रो करोगे तो एक सर्कल की फॉर्म में वेव बनेगी एट अ स्पीड ऑफ 3.5 सेंटीमीटर पर सेकेंड एट द इंस्टेंट व्हेन द रेडियस ऑफ सर्कुलर वेव इज 7.5. How fast is enclosed area increasing? So we want to find this. Now, the wave is in the form of circle. So, area of circle is pi r square. Area of circle, pi r square. Now, differentiate with respect to t. dA upon d, 2 pi r dr by dt. What is the value of dr by dt? 3.5. 3.5 into 2 is 7 pi r. Now, we want to find rate of change of area when r is equals to 7.5. So dA upon dt when r is equals to 7.5, 7 pi into 7.5, 52.5 pi. Area is in centimeter square and time is in second. So 52.5 pi centimeter square per second. Now the next one, question number 5. A particle moves along the curve 6y is equals to x cube plus 2. Find the points on the curve at which y coordinate is changing 8 times as faster as x coordinates. Now y coordinate is changing. Rate of change of y coordinate. Rate of change of y coordinate is 8 times rate of change of x coordinate. Clear? Now differentiate this term. Differentiate 1 with respect to t. 6 dy upon dt, derivative of x cube 3x square dx by dt, derivative of 2 is 0. dy upon dt is 8 dx upon dt, 3x square dx by dt. dx by dt will get cancelled, 88. So we get x square is 16. So x is plus minus 4. Now we want to find the value of y when x is equals to 4 and when x is equals to minus 4. When x is equals to 4, 4 cube 64 plus 2, 66. So we get y as 11. When x is equals to minus 4, minus 4 cube plus 2, minus 62. So y is minus 62 upon 6, 2 So we get y as minus 31 by 3 and y as 11 when x 4, when x minus 4, y is minus 31 upon 3. Note it down. Now the next one. The volume of the cube is increasing. Volume of cube is increasing at rate of 7 centimeter cube per second. How fast is the surface area increasing when the length of edge is 12? Write down. Let length of edge of cube is x. Let length of edge of cube is x centimeter. Now, volume of cube we have given. Volume of cube. Volume of cube is equals to x cube. यही होता है. Differentiate with respect to t. 3x square dx by dt. dv upon dt is 7. So from here we get the value of dx by dt as 7 upon 3x square. Let this equation as 1. Now surface area of a cube is 6 into side square. Surface area of cube is 6